Picking up where we left off in 2.1, we have this definition, two lines that form a right angle. The word that goes there is perpendicular lines. L and M are perpendicular. If they're perpendicular, we write that like this. L, and then an upside down T is a perpendicular symbol. So we have L perpendicular to M. That would look like, in a picture, that would look like M is one line, the other line is L, and to show they're perpendicular, you put a little square. That square shows that that angle is 90 degrees. Two angles that have the same measure are said to be congruent. A picture of that to show that these angles are congruent. We've got angle A, B, C, and angle D, E, F. To show those angles are congruent, I would put an arc through it with one tick mark on each one, or the same number of tick marks. It can be, they could both have two tick marks or whatever. As long as they have the same number of tick marks, then we can say they are congruent. That shows they're congruent. So we would write angle ABC is congruent to angle DEF. Right. Now sometimes the book, I think, does the angles to show they are congruent. They would do the angles they would mark them like this, the same number of arc marks. That shows that those two angles are congruent because the same number of arcs rather than the tick marks. Complementary. Complementary means that the two angles sum to 90 degrees. They do not have to be adjacent or touching each other. I could have a 30-degree angle way over here and a 60-degree angle on the other side of the page. And if they ask me they're complementary, I would say yes, because 30 plus 60 is 90. They can be next to each other, but they don't have to be. Then the other one is supplementary. Angles that add a 180 are supplementary. Now, I always said, when I was a student, I always had a hard time remembering which was which. Complementary, supplementary, 90, 180. So a silly little trick I use to help me remember that is I think supplementary, I think supper table. A supper table is flat, right? 180 degrees. So supplementary goes with supper table, which is 180. If you know that one, then you know the other one is going to be complementary, and it's 90. Adjacent. I just mentioned that word. Adjacent means that they are two angles who share a common vertex and a common side. Adjacent. A picture of that is these two angles. They share this vertex and they share this side. So they're adjacent. we've got an example here. All right. In this picture, angle ABC and angle CBD, this is ABC, this is CBD, are adjacent. Which two are supplementary? Or complementary? Which two are complementary? Yes, Nina.
Angle BC, B.
That would be this angle. That's 90 degrees. It's not added. It's 90 degrees by itself. That's a right angle. It takes two angles to be complementary. Shatis.
Angle. Trying to figure out what. Angle CDB and CBD.
Yes, that's right. Angle CBD and angle BDC are complementary. Because that's 56 plus 34 equals 90. All right. Supplementary. Give me a pair of supplementary angles. Which angles make a line? Shatis?
ABC
Yes.
and CBD.
Yes. For 146 plus 34 equals 180. So angle ABC and angle CBD are supplementary. Any questions? Okay. So in this figure, CG is perpendicular to GE, that's shown. AGB is 77. No, it's marked already. I don't need to mark it. It's 77. CGD is 54. That's marked. And FCG is 157. So we can mark that one. FCG, this angle from there to there is 157 degrees. All right. So DGE. What's DGE going to be? Yes.
36 degrees.
Right. 36 degrees. How'd you get that, Aditya?
CGD is 54 and CGE makes a right angle 54.
So he subtracted, right? So 90 minus 54 equals 36. Right. BGC. What's BGC and how'd you get it? Okay, well, AGD makes a straight line. So I could subtract BGA and CDG from that, and what's left would be the angle. So we take 180 minus 77 minus 54, and that's going to give me 49. AGF. So now we've got this as 49. AGF. How do I find AGF? Shatis.
You figure
Not just 77.
77 degrees.
Yeah, okay, so we take 157 and we're subtracting this. What else? Yeah.
And 49.
And 49. We subtract both of those. So we've got 157 minus 77 minus 49, which is going to give me 31. FGE. So now we've got this is 31. We found that this was 36. What's FGE going to be? We've done one similar to this already. How do I figure out FGE? Shatis.
The AGF, GGE, and FGE have to add up to 180 degrees.
Right. So you'd subtract, right? 180 minus 31 minus 36. 113. Okay, any questions? Now you're going to have a problem like this on the test where you have to figure out some angles and then name these pairs of angles. So students always have a hard time with this on the test. Okay, so make sure you go back at the notes and look at this before the test. Okay, this because like I said, there'll be a problem very similar to this on the test where we have to name all these things. So name one pair of complementary angles. One pair of complementary angles. Because of time, I'm just going to go right through it. Okay, one pair of complementary angles. We've got angle C. Let's clear this out. Let's clear it out here. Pair of complementary angles. We have CGD and DGE. One pair, name four pairs of supplementary angles. Okay? So 4 pairs of supplementary angles. So any 2 angles in combination that make a line. Now that there may be another angle within that. So what I'm saying is, so like I can take this angle, AGE, and combine it with this angle, DGE, and they make a line. Even though I have this line right here, this other angle in there, I just ignore it, right? So I could say angle AGE. The 4 angles, we'll do them right here. Okay, so we've got angle AGE and angle EGD. That's one angle. We could do AGB, this angle, AGB. Let's do it in a different color. AGB and BGD. We can do AGC and CGD, and we can do AGF and FGD. All right. Any questions about those? Does everybody see those? All right, now, let's clear that out. They're also going to ask you, it's not in the notes, you have to add this to the notes. It's name an acute angle. We'll do the 4 pairs of adjacent angles first, because that's what's in your notes first. So 4 pairs of adjacent angles. You could use the same 4 we just used. Right? Those are all adjacent. You could use the same 4 you used for supplementary. Some other combinations are AGB and BGC. These two are adjacent. They share this ray. They share this vertex. Those 2 angles are adjacent. We could do angle BGC. I mean, to find, yeah, we could do angle BGC and angle CGD. We could do angle CGD and angle DGE. Those are adjacent. They share a ray. And one more would be DGE and angle EGF. Everybody have those? All right. Name 2 acute angles. All right, there's plenty that you can pick from there. Acute is less than 90, right? So 2 acute angles. We could use angle AGB. This is 77, so it's acute. And we got CGD. CGD we know is 54, so those 2 are acute. 2 obtuse angles. Well, we could use the FGC. That's one. We know that's 157. We can even use that. We can use these without even looking at the picture. FGC is 157, so that's 1. And then another one would be. We could use the BGD. If AGD is 77, BGD would have to be 180 minus 77, which is 103. So we could say angle BGD. Okay, any questions? Now, it says pairs, so don't put 3 angles. When it asks for a supplementary, don't put 3, just put 2. There may be one included within those, another one.
Students, at this time, we are going to go on to a soft lockdown. So if you would please keep your students in the classrooms until this is over, I will make the announcement when we're all clear. Thank you.
You know, if you have supplementary angles like these 2 angles, they are supplementary. You may have another line, another ray right here. Don't name that other ray. Okay, it's just 2. It's a pair, so it's just 2. All right, clock problems. Okay, to do a clock problem, Find the measures of the hands of a clock at the following time. 3:30. So here's how you can think of a clock problem. How many, how many degrees, we want to divide the clock up. So each number on the clock, 1 through 12, how many degrees is it from 12 to 1, or for 5 minutes? How many degrees would that be? Sure.
30.
Yeah, it's 30. How'd you get that?
It's 360 degrees and there's 12 numbers, so I
Yeah.
divided by 12.
Right, yeah. So we take 360 divided by 12. So that tells us that 5 minutes equals 30 degrees. Okay? And that's what we're gonna use. So we don't have to use it on this problem, but what would that mean that 1 minute is? 1 minute is how many degrees? Yes, Nina.
6 degrees.
Yeah, 1 minute is 6 degrees. There may be some other problems where you have to use that, but for now, all we need to know is 5 minutes are 30 degrees. So, draw yourself a picture of a clock. And put the needed marks on there. So the minute hand is the long hand. It's on 6 because that's half an hour, right? That's 30 minutes. The hour hand, this is where it gets tricky. The hour hand at 3:30, is it on the 3? Where is it? Yeah, it's halfway in between the 3 and the 4. So there's our minute hand. So what you should do on these problems, the first step, take whatever minutes you have, this value, the 30, and put it over 60. This is an easy one. It's 1/2. 30 over 60 is equal to 1/2. Right? And so then you go to your picture and you count the whole sections of 5 minutes. So my whole sections of 5 minutes, I've got 1, 2. Come on. Let's go right. I've got 2 whole sections of 5 minutes. So I'm going to take 2 times, we know 5 minutes is 30 degrees, 2 times 30 degrees, plus, then we have to add in this fraction. So we know it's half of 30 degrees, right? So it's going to be plus 1/2 times 30 degrees. So that's going to give me, then I do the math, 60 degrees plus 15 degrees, which is equal to 75 degrees. All right, any questions? On that one. Okay, it's just a process. So let's do the next example. Let's do 9:10 instead of 9:25. So cross that out. We're going to do 9:10. I draw my clock. I put my minute hands on there. Or my 5 minute marks. And at 9:10, the minute hand is going to be on 10, on the 2, and the hour hand is going to be a little bit past the 9. So there's my minute hand. So we follow our process. We take 10 minutes over 60. That equals 1/6. Right? Then we count the whole sections of 5 minutes. So you always go the short way around. Okay, you go the short way around, so it'd be 1, 2, 3, 4. 4 whole sections of 5 minutes. So we're going to take 4 times 30 degrees plus, now, this is why I changed it from 9:25 to 9:10, because in 9:10, this is a little bit different case. Am I going to add 1/6 of 30 degrees? Is that what that fraction is when I go the short way around? It's 1/6 past the 9, but what do you need to add, Shatise?
But it's 5/6 because we're going the other way around.
Right, we're going the other way around. So yeah, from here to here is 5/6, not 1/6. So it always won't be this fraction you get. You got to look at the picture and see whether it's which way you're going, and it's 5/6. So we take 5/6 times 30 degrees, and then we would solve, and we get 120 plus 150 over 6, which is equal to 120 plus 25, which is equal to 145 degrees. All right. Now, when you do the homework, I want you to follow this process. Don't just look at it and guess, or this is a fail-proof way to figure out how to do these. Any questions on clock problems? We'll have a chance to, when we go over the homework, we'll have a chance to go over some more of these. There's typically questions about how to do these, so do the best you can. If you still have questions, we'll go over it next time. Yes.
Will it ever go down to a second or no?
No, I don't think I'll make you do seconds. I may make you do an odd number. I may make you do 9/13 or something like that. If I do that, then you've got to use the 1 degree equals 1 minute equals 6 degrees. If it's an odd, if it's not on a 5, but yeah, you won't have to do seconds.